Oh gosh, and here's Matt too. Fine. Hey, okay, so this is Coffee Compiler Club. Anything and everything to do with compilers and language runtimes and implementations and non-compacting, non-moving garbage collectors, generational garbage collectors, code gen, concurrency, typing systems, nil, not the nil, whatever. You're all being recorded live. I'll put the video up on YouTube generally within an hour or two these days. Well, a couple hours, it takes a while. Open mic, say what you want. I reserve the right to moderate. Never had to do it. There is a Google Doc that should be in your link. It's also in the chat now that we use for whiteboard space. And that's my opening spiel. Christine Flood, a longtime old acquaintance, is on. And I wondered if you, Christine, if you could share 10 seconds of what you're doing and why you're here, just really brief.
Hi, guys. I worked on the Java for a long time, both for Sun, Oracle, and Red Hat. But recently I've moved to the Julia computing company, whatever. And so now I'm working on a new language and its new challenges. And I thought I would check in with what everybody else is up to. So here I am.
Excellent.
So this is working for Julia, but not on the Julia programming language.
I am currently working on the garbage collector, the Julia garbage collector. I don't know if you're familiar with my work, but I've done a lot of garbage collection work in the past, including most recently Shenandoah for Red Hat. But right now I am looking at what they've got and how to get to where they need to be.
So would you say that there are specific differences where you design things differently because now you're not using because now you're not garbage collecting for Java, but you're garbage collecting for Julia?
Hi, that's exactly what I'm trying to figure out. They're running a lot of, they don't have as many small objects as Java does. They do a lot of huge arrays. Mostly I'm just looking at the allocation patterns and trying to figure things out and fixing obvious things that look wrong. I think that they're going to need a copying collector. I think they're going to want pointer bump allocation. I have to believe that, but I want to make sure that I've looked at enough of their programs to be sure that, you know, what they have now isn't giving them something that I haven't thought about yet.
Dun, dun, dun.
Yeah, I feel like the advice I've been given in Julia is try not to allocate. Allocate one giant thing at the beginning and then mutate your array.
Yeah.
They work really hard to do that. And it makes me want to, this is being recorded, but I'm going to say it anyway. It makes me want to slap somebody. But hopefully, you know, if we can figure out how to give them, without any performance degradation, give them a copy and garbage collector so they can have pointer bump allocation and they can have an old generation that they really, really, really don't have to look at, then maybe that kind of advice will go away. I mean, way back when in the Lisp world, and I worked for Symbolics, and people would say, you know, I have this artificial intelligence thing that is 100% garbage free because we manage all our allocations ourselves. And it was proved to be wrong then, and hopefully it'll be proved to be wrong for Julia.
I'll say Symbolics, you didn't bother to do garbage collection on the Symbolics, which had the hardware support baked in for garbage collection?
I was very young then.
Okay, fine.
Even being very young then still makes me old.
Well, I worked on a Symbolics a long time ago. Texas A&M had one way back in the day.
I don't even know what a Symbolics is. From context, I'm guessing it is a Lisp in hardware machine?
From the 80s, maybe?
Yeah, I worked there in the late 80s. They managed to limp along till the early 90s.
Yeah.
I feel like now people have pretty well settled on just JIT the Lisp into an assembly and use a nice 3-register.
Yeah. Now, Hotspot proved that you could just jit the damn code and then you didn't care what the underlying hardware was, except you wanted to be fast.
What's Lisp?
Sorry,
We still
Cameron.
want tag data.
I said, what's Lisp?
Oh, yeah, fair enough.
Before we leave the garbage collector topic, I have a kind of general question. I have a problem that I'm investigating right now. And if I don't include in this application of this test case, a bunch of calls to like system.gc, this is Java, of course, it'll run out of memory. So if I don't poke the garbage collector to clean up, it doesn't clean up and it runs out of memory. But if I do poke it, it works fine.
Cool.
So like, isn't the garbage collector supposed to do this by itself?
Yeah.
So
okay,
just assign the garbage collector is broken.
Yeah. So first of all, you know which of 17 garbage collectors are you using?
Well, I'm actually running my test now with all of the garbage collectors available in OpenJ9. And so far,
well, there's your problem. You're using OpenJ9.
You think?
Yeah.
Well, I work on OpenJ9, so it's not really an option to say screw that.
So
Run it on a reasonably recent version of OpenJDK and see if the same behavior shows up. Then you're pretty clearly pointing a finger at OpenJ9's garbage collecting heuristics are blowing up.
I think that's where
I think you have to ask where you're running out of memory. Are you running out of direct byte buffer memory?
Yeah, right. No, I was getting there. That was next, but I wanted to.
There's no direct byte buffers involved in this test. So it's further complicated by the fact that there's a special class loader that loads a whole pile of classes, and those classes have a lot of static data. And all of that, the class loader and everything attached to it is supposed to go away when you close this file, or let go of the handle of the thing that you get by going there.
That's another common failure of earlier garbage collectors, is not collecting the, whatever you want to call it, permgen, or the space where the classes go, and running out of permgen as opposed to anything else.
Right. So anyway, like I say, I'm quickly coming to the conclusion that this particular garbage collector is broken.
It's also possibly a heuristic, Keith. So if you increase your heap size by 10 to 15%, if it still happens, then it's a bug in the VM.
Yeah, you might be able to flip it, right, poke the heuristic.
So my little test, if I run it with a 640 meg heap, all collectors fail after a few iterations, but I bumped it to 800 megs and only one of them is failing so far.
No one needs more than 640K.
That sounds like a heuristics issue, because some of the garbage collection algorithms, if they notice a pattern where they're only able to free up a certain percentage of memory, they will treat that in a subsequent collection as an out of memory error.
Yeah, they're not making enough progress. Yeah.
So at one point I may decide it's worth, trying to distill, or like remove the dependency on OpenJ9 features for this test, and see if I can't, provoke this behavior with stuff that I could retry on Hotspot. And
so the other game to play here is look at what you get, what information you get when you get an out of memory, in case it's indicative of your out of perm gen versus out of young gen or old gen or whatever.
Yeah, well, those terms don't apply to all the collectors we have.
Yeah, I know, but generally, not always, most garbage collectors will have a separate allocation space for class statics classes, and that can be run out, especially if you have custom class loaders.
Yeah, like I said, so this thing, it loads up a bunch of stuff.
Yeah.
And then I just say, okay, forget all that and try again. Right.
Yeah.
So all of the garbage should just, get out of the way and let it should work the second time the same as the first time, and so on. Right?
No, but what I'm saying here is that doesn't always work.
Yeah.
And throwing in a forced GC at the point at which those objects are dead may let the GC then clean them out, but having a GC happen, the GC may not trigger when you have lots of space in young gen or old gen, but no space in perm gen. And you need a perm gen collection, which requires a full GC cycle. It's, there was a bug eons ago in Hotspot where finalizers would only run on a full GC and all file handles had finalizers. And when heaps got big and file handles were in high consumption, you'd run out of OS file handles without running out of the heap. And so you'd get a random crash because you couldn't get a file handle from the OS, but it wouldn't trigger a GC cycle, a full GC cycle, in order to clean out the finalizers.
Mm-hmm.
And, there were multiple bugs there, of which they all got sorted eventually, but there was a callback put in that said, if I'm out of file handles, force a full GC cycle. And you have to have those callbacks anywhere people have put limited count resources that require some sort of full GC cycle to clean out. And they're not always, there's a funny backdoor paths to full GC cycles, and they're not always there.
Yeah, I think that's what Mark was asking about with the native buffers, because it works at the
same for native buffers. I have totally had an 8 Java 8 run out of memory, out of native buffer memory, and the complaint you get is out of memory that you eventually can sort. I eventually sorted back to native buffer, but it wasn't obvious.
Yeah, so none of this native stuff is applicable to my test case.
Yeah.
It's all just stuff on the heap, where there's classes or
right. Custom class loaders, I'll claim should throw a red flag for GC.
You mean in the application design having a custom class loader?
No, if you get an out of memory, you get a GC fail and you have custom class loaders, there's probably an interaction that's bad. Look there for an interaction that's bad.
Yeah. Okay.
Can I ask another Shenandoah question to Christine?
I'm here.
Oh, yeah, that's why I want to ask all my questions about garbage collectors. So, I recently saw that, like, in Shenandoah version 2, they or you, or I'm not sure whether you have been involved in that. The garbage collector got rid of the forwarding pointer in the object header. Was this planned from the beginning that eventually Shenandoah would get rid of this, or was this some new insight that allowed getting rid of it?
I swore it couldn't be done.
All right, okay.
This is all Roman. I'll give him credit for this. He figured out how to do it. I thought that anything that slowed down the read barrier was going to make life worse, but he managed to figure out how to do it efficiently. And that's the difference between Shenandoah 1.0 and 2.0, I believe. And it's, yeah, he is a really talented hacker. I have a lot of respect for him.
Okay, crazy.
Excellent.
Yeah, when I read the original Shenandoah description, it felt like the forwarding pointer was like one of the innovations that allowed a lot of the operations in Shenandoah that wouldn't have been possible in older garbage collectors. So I was really surprised when the forwarding pointer got removed. But I guess the solution is stuffing more bits in smarter ways into less space.
That's exactly right. There's still a forwarding pointer. You just have to do some bit twiddling to get it.
Yeah.
I guess you
one-word header.
I guess you replace the class pointer with a forwarding pointer and have then a bit or something that switches the meaning, or
I don't know what all the bit twiddling is. I'm not the person to ask. But Roman is really nice. I bet if you send him a thing saying you're interested, he'd tuck your ear off.
Yeah, that would be nice.
As it seems, bit packing always helps.
Yeah.
So what is the work that needs to be done in the read barrier?
You need to figure out where the new copy of the object has gone. And so you need to, he figured out that you don't need it in the 2 copy because you don't need it in the 2 copy. And in the from copy, he figured out a way to cram more into the one word header so that he can pull that out, as well as, I guess he has the class pointer in the to copy. You know what? I don't want to say the wrong thing, but my best understanding is the class pointer is already in the to copy. So as long as the old copy just points to the new copy, you can still get to the class pointer. And as long as you don't try to do anything with the old copy, you should be okay. But don't hold me to that, because I haven't
Okay,
had.
so
very
I
much
hit some
involvement.
object and it's like, dude, I moved, like go to the new thing. And then you do all your lookups against the new thing.
Yes.
So basically the only thing you need in this tombstone of the old object is a like, dude, no, go over there.
Sure. I believe that to be true.
The other thing I'd suggest is feel perfectly comfortable to be wrong with your guesses. Because we often find we are.
With Java adding specialization and value types really soon now, do you have an idea which garbage collector profits most from having small types not being objects anymore, or not being reference objects anymore?
Cliff looks like he wanted to answer, so I was going to let him have a shot. But
Open mic.
I'm sorry, I have a new person showed up who didn't get an invite, but he got a by indirect invite, and so I was sorting out with this guy who he is and where he come from. You missed old history, but a long time ago when I first started this thing, the porn bots showed up first. So when unknown people show up, I have to go pay attention.
The porn industry is very motivated to have good technology and efficient.
They are, and they have some amazing technology. It's true. So I'm sorry, I wasn't paying attention to the question. There was something about forwarding pointers, and I know the Azul collector fairly well, so maybe I can answer, but I didn't hear the question.
No, the question was, if small objects are now stack allocated for whatever reason, which garbage collectors are going to profit more?
Oh,
and I don't have an answer.
Okay.
Yeah, right. The number one story is that all the allocators work in the background, and count of objects doesn't matter as long as you have background cycles to burn them out. So I claim that that's not shouldn't impact lots and lots of people. If you have any kind of reasonable background collector, count of objects is not the issue.
I think the bigger difference is going to be that there's now going to be a notion of immutability possible in Java, which has not previously been possible. And that should open up, if you have an application that has an overwhelming percentage of its data in an immutable form, that should open up some possibilities.
Well, so you quit having to follow possible changes through these objects, and then that happens already with card marks. So your shavings would be, for instance, to the JIT removes card marks. Not a giant win.
Right, but you could, for example, split the GC into two parts, because theoretically you can continue execution while you do your copy compact of the immutable data.
So so mostly GCs do this already. In the sense,
they have to have a barrier to protect it.
Well, that's the read barrier that Shenandoah and Azul both have. Once you bite the read barrier cost, then you've paid already, and it doesn't matter. You have your split and you go from there. Then the fact that the stuff's immutable just means that you quit seeing changes in it and it stabilizes really quickly. You already have all kinds of cutouts because people have immutable code that they can't declare or enforce, but they happen to have it. And the GC takes advantage of this by the nature of using, for instance, card marks to gate sections that are not being changed, so I don't have to go fiddle with them. You have remembered sets. That's the other piece which says I only need to go look in this section over here. A lot of this stuff happens already. So I claim that moving things onto the stack, what you really gain out of that is stack reuse. which goes to reducing memory bandwidth and getting a lot more L1 cache hits. So that's a performance for everybody on the main mutator. The mutator wins because he doesn't take an endless stream of cache misses on his allocations. But it's not related to garbage collection per se.
I would have imagined that, okay, then it's probably more related to immutability, that if you are able to have immutable things and now you don't separate those immutable things with references, but you have some kind of fixed size structure with like 100 things in there that aren't references. That's like a huge graph of like 100 references the garbage collector doesn't have to traverse anymore.
Right. So what I'm saying here is that the garbage collector mostly doesn't traverse things that are immutable anyhow, because they don't trigger any read barrier or write barriers. So the job's just done.
Yeah. Okay. Understood.
So right. So it's bump pointer allocation. Small objects are cheap to allocate, but they still burn your memory bandwidth. So going to a stack saves you memory bandwidth, but doesn't help. That helps the mutator, which is what you want, but it doesn't matter to the garbage collector per se. Then there's a question of, I have to go walk all these tiny objects in the universe and I put them on the stack. Maybe I don't have to walk them, or walk them differently or something. And the answer is, well, if they are made in high volume and they die young, which is the generational assumption, then you don't walk them anyhow, and it don't matter. If you have a bajillion tiny objects that are alive, but you're a background collector, you're going to walk them in the background. It don't matter anyhow.
Why does collecting lots of little objects in the background not actually matter? Because wouldn't the thread that is doing the GC like go make a bunch of memory pages dirty and force other things to pull those pages back into their local cache?
So, well, okay. So no, in practice, statistically speaking, no. In practice, in theory, yes. In practice, what really happens is the mutator gets to it first. He triggers a read barrier on something he wants. He's got the wrong thing. He updates it. He's done. He corrects himself. He corrects it in memory because he's already gotten his cache, and he moves on. Okay, next time he touches it, it's already corrected. He doesn't fail the read barrier again. That's the design of read barriers in general. You pay the big cost once, and it's the first person to hit it gets it. Okay, the garbage collector runs by it. It's done already. He reads it, but it's a shared cache. He's not changing it. Moves on. Life goes on. No change, right? Meanwhile, if the garbage collector is instead busy, updating things that you're never going to look at, you're never going to look at them, and they're out of your cache, and you don't care. So usually, what you just said was, it's expensive if there's a set of things that the mutator has to look at but hasn't looked at it yet. The garbage collector is going to change it, and he's busy getting to it first. And does this make any difference? Everybody's going to do. It's going to flip values from old to new, no matter what you do. So either the garbage collector got to it first, or the mutator has to do it before he makes progress.
So it tends not to be a problem, because even though there is a background thread, it is the foreground threads that are doing most of the work on these objects.
No, it's not most of the work on this. The foreground thread do most of the work on their live set of the moment. Right, so for some short window of time, they're busy taking fault. You flip the read barrier phase. Everyone takes faults for a little while they correct their local tiny live set. Not very long in the future, they've got a working set that's big enough that they're not faulting very often. Like their fault rate falls off very fast. We called it a trap storm at Azul, where you hit traps, read barrier traps at a fairly high rate at the phase flip for microseconds, not really milliseconds, microseconds. And then it faded out pretty quick. And then the background collector, like, burns memory bandwidth behind your back, and he burns your core behind your back. And is this a substantial cost? On a Azul box, never. It had memory bandwidth out the wazoo. On an x86, you can be out of memory bandwidth, and somebody has to pay the price. So it could, in theory, cost you, but typically boxes are not run at max capacity, and they're not actually out of memory bandwidth yet. As H2O doing big data machine learning, we'd run you out of memory bandwidth all the time. Most of the stuff I see people run on a random server somewhere in a cloud, you got memory bandwidth floating around. The background collector doesn't hurt you. No problem. You don't use the memory bandwidth, you lose it. So might as well use it.
Yeah, I may be in a weird part of the design space, but I feel like my bottleneck is always the network bandwidth.
Well, I'm talking about memory bandwidth, not network bandwidth. You could be in.
Yeah, normally my things are rate limited, not because they're out of memory bandwidth, but because they're out of network bandwidth. And they're
yeah, okay, fine.
waiting for other computers that are,
yeah, right.
a millisecond away.
Right. Which means, by the way, that, that collector doesn't hurt you any. Whether it helps you, I don't know, but it didn't hurt you any.
So Aaron, that's quite, there's two different issues there. If it's a millisecond away, it's quite easy for it to not be bandwidth limited at all. Right. If you're doing synchronous round trips, a millisecond is infinite for all practical purposes.
Yeah. You're losing a million ops per round trip.
Right. So you could have, 200 terabytes of bandwidth and be using, 0, or have a 10 megabit Ethernet and still not be saturating it. So the millisecond can be the gating factor, not the bandwidth. Just for thought.
Memory's the new disk, or network's the new memory, or tape, or something. Yeah.
Well, it's the other reason that you want everything to be async, whether it's locally or distributed or whatever. Any ability to achieve parallel efficiency is going to be predicated largely on being able to pump that stuff asynchronously.
Yeah.
I think there's a trade-off in developer understanding with synchronous things.
You bet. Absolutely. Yes.
Yeah.
Like I've worked on plenty of systems where you look at it and you go, this obviously should be a high availability thing that merges the data structures, and you could make this much better with CRDTs, but also there's one developer working on it and the consistent system is good enough. So we're going to do this as one core that applies each transaction one after another and get our linearizability that way.
And this is the challenge with, the programming models that we have, because ideally you'd want to be able to write all of your code in a, synchronous fashion and still get all of the benefits of a continuation based.
Yeah, I like to claim there should be a way to write it where you understand its continuations, but you understand the continuations. Certainly at H2O, there was a layer that encouraged continuation style that had some boilerplate you had to do. You didn't get any compiler support, but the underlying semantics you got were reasonable to understand and deal with. So several systems engineers, not just me, but 5 of us, could understand and build on it. And then from there, we could get, things that would be async to the T and hugely parallel and distributed and scale out and get these big data things to burn memory bandwidth, not network latency between nodes in the cluster.
To what extent did you break stuff up yourself? And to what extent do you ask developers to type async and await into their code and be like, this is a spot where you can go do some continuation passing and break it here?
So if it was a mathematician writing a math algorithm, we told them to write Fortran code in Java, and we did it. So all the big array passes, we automatically did behind, like the system just did. If you did take these 2 giant arrays and walk them both and do some sort of compare, contrast, model building story, whatever, you got a 2D table of this and that. That was all done by the system. If you're one of these 5 guys who are doing systemsy work, we had a well understood boilerplate pass that said, and here we can break it up. And then we manually looked at where we would break up things. So you're doing hyperparameter search on models, you went down the different hyperparameter paths, and you wanted them all to run asynchronously and come back and you would gather best effort, whatever, and people would go do that thing, right? Basically, I did the first cut with doing the big data scale out using a kind of map reduce paradigm with pairwise reductions being deterministic in order, but asynchronous compared to each other, either over the wire or local, memory local. And once we saw the pattern, how it worked, it was pretty easy to get other people to pile in. There was a thing that you said, and here I have to wait on a result and I have more things to go do. I insert my boilerplate and then I pick up the things I'm going to go do. And if they're simple, I put them in line, and that's effectively async, I wait. And if they're more complicated, I said, and here I hand you off this other set of tasks that are waiting on this guy to complete. and you went to a dependent task model. So you could either do it as a inline async await kind of thing, or you could do it as a task model, and the developer made a choice between how much trouble he had and wanted to deal with. So it worked pretty well, actually. We got, like I said, typically we could slam the box and burn all cores and memory bandwidth and get to an answer still to this day, like 10 times faster for the same amount of hardware as anyone else. It's pretty amazing. So there's a thing there to be done, and Cameron's sort of heading the right way. I don't know that his model's the one I would necessarily pick, but I think there's a goodness to separating concerns and saying this is this, but I need something from over there, and somehow I'm making the back and forth look more transparent, and therefore I can get more parallelism out.
To the best of your knowledge, no one's built SQL on top of H2O, have they?
Not SQL per se. I certainly did
but relational model stuff, yes.
I did the TCP/H queries, so the set of 16 of those queries on H2O, and got numbers that were as good or better as the best modern state-of-the-art, best of best read guys doing TCP/H query numbers. So I was clearly able to essentially tie custom hardware on custom big data guys doing custom databases with TCP/H queries. And I did this in like a couple weeks of just whacking on the queries in H2O, like very straightforward. Now the mapping of SQL in general, like the TCP/H queries are well understood for 40 years. So mapping them to a query plan, everyone knows how to do. And that query plan maps to H2O pretty straightforwardly. There wasn't a whole lot of fooling around going on there. It went in straight up. General SQL queries to an H2O model, I don't know. That's a query planner for a SQL. That's not my skill set.
Okay, I have a question about H2O. So I was reading this old blog post, which I'll paste. It was about concurrency and exceptions.
Yeah.
And so the question is, like, what do you have if you have, say, like this parallel for loop, and like, let's say it does a division in the for loop, and every, 256 element is 0.
Yeah.
So it ends up throwing a division by 0 exception.
Right.
And so you have all these different threads and all these different computers, and they're all throwing exceptions. And so the question is, like, you report the first exception, you report all the exceptions.
We worked through all this. So what we did was, so the common pattern is you wrote something broken, everybody threw an exception. You had a terabyte of data broken up into a million chunks that were running a million elements. You got a million exceptions. What the fuck do you do, right? So, and you want to stop launching new things because, the task queues are full of pending work that are all going to throw exceptions anyhow. And you need all the results. You don't have any of them, so it doesn't matter. So, okay. So the first guy who throws, you catch it on your local box. You basically wrap the exception up. You unwind it to the network crossing, and you serialized it, deserialized it, and added anything you needed locally, and you got an exception back that you could catch. So you said, and please, sir, do a map reduce job, this map reduce job on this giant array. And it throws in that map reduce job through an exception, and you got several things back. You got one at least trace that was the complete trace, including it unwinding through the cluster. So it threw over here, and it went through the network and threw over here, and you got the full shenanigans all the way down the line. We got a count of those that looked very similar. Hey, I didn't throw this once, I threw it 150,000 times. You got a second and a third trace if you had different exceptions, but then we cut it off and said, you're dead anyhow, but we'll give you some extra clues in case you had multiple fail modes. And a total count of all the exceptions that were ever seen in this attempt here. And that came back to your local desk, which you would catch in your debugger, like you're in IntelliJ. IntelliJ would pop it up and say, I threw a division by 0 error, and here's the stack trace. And the stack trace at the bottom would say, I'm on node X in the cluster when I threw it, and you could follow it through. And in fact, it was perfect. IntelliJ would pop you to the source code at the line you threw the exception and be right there. Now, if you were running the job as a node local, as a machine local variant of a cluster, which we did all the time for development work, you'd have 5 H2O nodes on one machine. IntelliJ would connect to them all, and you'd actually get the exception at the point in the virtual node, in your local machine where you could debug it there. But if you instead just got it in your continuous integration fail or whatever, you would get the stack trace back to the source line of the guy who threw it, plus this count, like I said, plus this count of, and I saw this 150,000 times and whatever else other thing. So that required us to map reduce exception stack traces back. So one of the returns of the map reduce job is the reduction you're trying to compute. One of the returns is the set of exceptions that came with it, including the roll-up counts. And I kept one, and I got another one that looked like this guy, so I added to his count versus it's another exception and whatever. So there's a couple of things that came back. But yeah, that was like a big deal when I put that in to understanding, because it kind of went from a hard job to diagnose weird remote exceptions for the 5 of us who were doing really systems work, to a point where mathematicians writing math code in Java could see the stack trace, and 90% of the time they'd snap to it and say, oh, okay, wait. And then they would go fix some array index calculation they had screwed up and go again. It was all fine. So big step in usability to map those exceptions all the way back to the desktop.
Okay, but I mean, but in terms of aggregation, what you did is you basically did this matching thing. That's like,
yeah,
okay, and then you had like 5 or 6 exceptions that were different, and then you cut it off.
Yeah, there wasn't any point in the map reduce job was dead, right? It wasn't going to produce a result, so there wasn't any point in collecting anything except the first one, really. And then there was a bunch of performance things where, often the bug was, because it was buggy, it would throw the next piece of work and the next piece of work endlessly, and you'd never run out of work to throw. So you had to pretty quickly go back to the queues of pending work and flag them all as you're dead now. So when they came off the queue, they would get ejected, and the queue had other work that wasn't dead. So you couldn't just flush all queues and abort the whole system, like reset the calculator. Hit the clear all button on my TI. I couldn't do that. Hit the clear all button and walk away. You had to actually filter it. So there was always a race between the guy who was throwing an exception, walking up his reduction stack, his pending set of log tree reductions, because every time he walked up a layer, he would set the bit saying, don't do it, right? To the work queue, like pulling something off and deciding to launch the next job, which was going to throw the same fucking exception again. Right, so no. But like I said, we sorted it out. It took a little while, but we sorted it out, and it was totally worth it.
All right, that's all my questions. So.
Yeah, killing a fanning out thing is always an interesting.
Yeah, your fork bombs.
Yeah, you're basically trying to kill a fork bomb.
Yeah, you're trying to kill a fork bomb. Yeah, great. Exactly, it was tough. So we played a lot of priority games. Java lies about priorities pretty big time and can't be delivered on a lot of OSs, whatever. But we played a lot of priority games. If you knew you were throwing an exception and you were crawling it, you could get permission to raise your priority to max and exceed all other things that would otherwise launch. Like all the worker threads would go back to the queue and they go to the highest priority queue and pull. But if somebody was throwing, he could throw a flag says I'm higher than anyone else, basically, and get the Java priority to be raised. And he would go to all the queues and tag his piece of data as fast as he could, and that would cut it. And the race was on, and multiple cores were still going, so you always had lingering exceptions coming back. But and until we did a bunch of those steps, yeah, killing the fork bomb was unreliable. It was bombing away in the background while you're trying to get something else done somewhere else.
The other analogy you can think of, though, the fork bomb, is it's really no different than a compromised certificate, in a sense, right? Because you can't contact every browser in the world to say this certificate has been revoked.
Yes.
Right, so it's built into that protocol. So you can think of it as there must be some periodic way in which, machines in a distributed environment will validate their understanding of what's proper and what's not.
Yeah. And of course, you had to pass it over the wire as well. So once the failure worked its way up in a local reduction, it then had to go over the wire. Which
You definitely have to build in back pressure understanding into a protocol, but you also have to build in the ability to preempt the message queue for higher priority messages without.
Right. Yeah. Well, that's what I say. H2O, we went down this line of we ended up with priority queues everywhere, and that was one of the reasons for that. And the back pressure was there as well. And that was all done with these high priority queues. It's all sounded like, I was fond of saying we took embarrassingly parallel problems and ran them embarrassingly well. And it turned out to be super hard to take an embarrassingly parallel problem and run it embarrassingly well. And that's why H2O is still as fast as it is, and much faster than like almost everybody else. It's actually a really hard problem. Fun stuff. All right, what else? I'm going to drag up AA updates. They're very boring this week.
Yep. AA status.
Yeah, AA updates, very boring. So my approx function, what the hell is my approx function? My approx function is not monotonic, and I finally figured it out. I figured out how and why, and I finally built it to fuzzer to fucking attack it in all possible ways, and came up with a bunch of reasons why. And then I'm busy building an approx that's actually monotonic. So
the kind of idea of the lattice was that approx would be monotonic.
Exactly. So you'd think so. So it turns out approx wants to have 4 key properties that are less obvious, more obvious, less obvious. So the first is it has to approximate. It has to reduce the size of an ever-growing type. And the second thing, it wants to be self-monotonic. If I take a type T and I make an approx of T, I want T to be is a approx of T. Now, that sounds easy, but it turns out that there are a bunch of holes where it wasn't, and it could be.
That amounts to a lower bound, or it has to be at least T, at most T.
Well, it depends on which way your ups and your downs go.
Yep.
It's heading for less knowledge of the world.
Mm-hmm. So it has to be at most T. So
like I said, I don't know your ups and downs and my ups and downs.
Yeah. All valid values of T need to be valid values of approx of T.
That's correct.
Yeah.
And the usual story is approx has, sections that went to bottom somehow. But I want prox to be, so the third property is that it's, the fourth property is that it doesn't suck. And that the easy way to make a prox work and suck is to chop everything to bottom. And that's—
I feel like your first 3 were expressible as lemmas. What does suck mean here?
Doesn't chop everything to bottom.
Okay.
Which means, what it really means for me is that if I have a cyclic type, if I'm starting my lattice at a high and relaxing it down low to get the optimistic good answer that is valid, during the relaxation process, if you have cycles in the program, you have loops, and you have types that are going on, you're fucking making a linked list that's ever growing. For I equals 1 to n, make an element of linked list of I, of pointing to the next element of I, whatever. You're doing something like that. You'd like to get a cyclic type out. So if the types start high and they begin to relax down, when they pass through this point where a cycle is possible, I would like approx to say, become a cycle, as opposed to approx to say, and here I chop you to bottom.
So you want to represent it at this point as a recursive type.
Yeah. And otherwise, everything in the system supports recursive types. It's all reasonable. I have all the infrastructure to handle recursive types. That's fine. Mm-hmm. But now which is the recursive type, and what are the rules that make it valid as an approximation, such that it is a relationship that's passed and it's a guaranteed, size limited. So the first step of approxing means something like, as I walk through a series of pointers and structs, if I see the same alias class twice in a row, I'll claim I need to wrap it into a cycle and be done. some limits. So whenever I build an infinitely building type, there's always some alias class that shows up over and over and over and over and over again. Somebody's got a linked list node element, or somebody's got a whatever, I don't care what you call it, but you get an endless stream of the same thing. So I chop it at some count, and the count doesn't have to be 1, but let's just call it 1 for easy sake. Okay, so that's the approx version. Self-monotonic, T is our approx of T. Monotonic, which means that if T0 is a T1, then approx T0 is a approx T1, which is also, so where's the damn, I see confusion. Where's the docs here? Let me go find my docs. This is like fairly straightforward here.
So how do you keep it deterministic? If I have something that's going ABC, 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 ABC,
yeah,
that type can be ABC repeat, or
right.
BCA repeat, or
right.
CVA repeat.
Right. So in the land of cyclic types, those are all ambiguously the same. I literally have a cycle, A to B to C to A. Now, and anybody else points at it, they're pointing at the B, or they're pointing at the A, or pointing at whatever, but once they hit the cycle, around and around they go. And I represent them as a cycle, and that's identical whichever clock tick around you go. So you get exactly one of those. That's the interning, the hash cons interning happens. But how you print it out and how you think about it might depend whether you started at A or you started at C. But internally, there's only one. So what was I doing here? So yeah, T is a approx of T. That's one of my things. Let's see. Here we go. Do this way. 1. Why did it tab on me? Okay, fine. T0 is a T1, you capitalize, then T0 dot approx is a T1 dot approx. So there's what you have to have, or what I want out of yeah, right. Not equivalent to bottom is the yes. So I lived for a while knowing that that number 3 was on again, off again, and I didn't think it was an issue until I finally proved to myself test cases where, because I apply approx in a loop during this large global analysis, I'll either infinitely recurse if it's not monotonic, or I will go backwards, which is equivalent to infinite recursion. So it has to be a monotonic. So once I got that, and I got a test case, and all these test cases are from this damn piano arithmetic I'm doing in the type system. It's like huge, enormous, like horrific things. I said, let me just try a fucking simple fuzzer. Sure enough, simple fuzzer popped out, example after example, simple examples. So I worked down, a big pile of those, and then I have some old tests where I wrote some manually large cases, but they didn't, because they weren't a fuzzer, they didn't cover enough ground. And that's where I'm at now. I'm working my manual difficult cases, and the fuzzer has caught a lot of other cases, and I can turn the knob on the fuzzer now, of course, with the fuzzer, and I'll do that some more.
So I had assumed that approx was always a function of 2 types.
No, that's the trick, actually. That's why you need number 3 there.
I get the impression that approx should pick a type that subsumes the, if T0, you have to pick T1 because T1 subsumes T0.
Let me show you an example here. Oh yeah, right. So what's going on here is,
so can approx give me back the same thing I gave it? If I say approx of 3, it's not allowed to tell me 3.
Yeah, it is. 3 has no, but the current version of approx is monotonically smaller. And as part of that, I'm going to claim if I see the same alias class more than once in a row, I'm going to chop it to 1, once, only appearing once. So 3 is no alias class at all. It's an integer. So approx of 3 is 3.
Why isn't approx of 3 like int 8?
Because 3 doesn't have a growing issue. Doesn't infinitely grow. If I merge 3 and 4, I get int 8. If I merge int 8 and 5, I get int 8, and I'm stable and I'm done. If I say for I equals 1 to a billion, I merge, 3 and 4, I go to int 8, I merge int 8 and plus 1 of int 8, I go to int 16, and a couple go rounds, I hit int 64 and I cap it and I'm done. So the for loop that counts on integers hits int 64 pretty quick, same as the widening operation in hotspot I talked about, months ago. You widen so many times, you hit the max int, you're done. So that path is okay as it stands because it already has a widening cap.
So I'm going around this loop where I say x equals x plus 1.
Yeah.
So 0 becomes 1. To represent both 0 and 1, I become an int 8.
Yeah.
Int 8 plus 1, 16, 32, 64.
Yep, and you're done.
When am I actually calling approx in this process? Because it feels like all I'm doing is meeting two types.
Right. So there is no approx in that process because of the structure I'm currently holding on to the integer types with. In hotspot land, I held integer types with a lower bound, upper bound. That was be 0 to 10, 0 to 11, 0 to 12, whatever. There I need to have an approx and a widening operator, where if you say, oh, the range of x is from 0 to 1, I'll add 1 to the max. Now the range is from 0 to 2. Now it's 0 to 3, now it's 0 to 4, now it's 0 to 4 billion, right? You'll be 4 billion to get to the end. So what I did there was I had a widening operator, and I said, I apply the widening operator max of 3 times. So any given guy had a count of widenings. He widened once, twice, 3 times, bam, smacked him to int and walked away.
So approx means I've done enough merges that I've burnt my willingness to widen by small amounts.
Yeah.
Now I need to take a big step.
That was the integer version.
So it's kind of an alternating big step, small step.
It only took small steps up until it hit the big, until it gave up, and then it went to big step. And the goal of that version of range checks was to catch small switch statements with small integers, which it mostly did fine on, right? And
I would say that it tries to trap some small ranges so it can become. Yeah.
People had for loops for I equals 0 to 10. I could ponder unrolling the loop and shit like that. I wanted to track that I knew that it was a max of 10 or whatever. So those were, that was its goal, and it did its goal just fine. Here I have a complicated types where I append a structure continuously. So let me go see if I can write an example here that makes more sense. colon 0 colon n, I'm just making up some syntax. And then I want to say, new list element is, here we go. So list x equals null, new list of x comma I, and x is equal to like this. Okay, so what's the type of this, So it's an infinite list of things with consecutively larger ints. So if I say precisely what is x on the first pass, it's nil. When I say, oh, it's list, single list of nil and the number 0. Then it's a list of nil and 0 of 1. And then it's a list, and then it's infinite lists, right? You keep adding lists. Okay, so now you want to approx, and what you get for this, so if I start without the approx, I get a list of dot, I don't want to deal, right? Finally ends up with, 2 comma, 1, comma 0, whatever. Fine. Okay, this is too big. So I'm going to approx it, and I want to say it's list of, I need a type for the back edge. It's list question mark, comma, int 64. So it's this type where I say it's a cyclic list. So approx wants to do something where he says, I have a type and it's growing. Oh, I see list twice. Let me chop you off by saying you're a cycle. And then I have to merge, or I have to meet the other parts that are not part of that cycle, and that's the int 64 at the end. And this will get me in, 2 passes around the loop. It'll get me exactly what I'm looking for.
So what if I'm using this as a terrible way to encode a dictionary, and it's list of int, list of string, list of int, list of string, list of int, list of string?
Right. So now I have a knob, which is how much unrolling I'm willing to allow to happen before I cut you off. So if I unroll twice and then I cut you off, you'll get that.
So if I was alternating between ints and strings in this pattern,
yeah, I could get that by
you would say I was a list of a list of string of.
Yeah.
It
Yeah.
should be unrolled 3 or 4 times to see that the types alternate, so we can squeeze them back to say it's a list of string or int.
Or,
If I'm going T1, T2, T3, T4, and I've got too many of them, then it's just gonna be like, this is a union of all those types.
Yeah.
That's correct.
And you should end up like something like any, because it cannot represent or a list of some unknown type.
Right. And that point, I'll complain at you that you have ints and non-ints, and I'm going to have to box the ints, and you better give me permission to box ints because I don't box by default because that's a performance hit. That's a major performance hit.
If we continue with the examples, we should share screen so our audience.
Yeah, I don't know. Well, let's see if we go continue the example. Maybe we do. I'll hit the share screen here and maybe helps people. Fine. Share, boom. Yes. Okay. Somebody's hacking away, and do the list of string thing. There's your nice syntax. Boy, I love this syntax editor. You had to make your code for the second guy. I'll write in the code for the second guy while you're writing in the type for the second guy, right? I'm going to take your first example here. I'm going to say new list of whatever. New list of space. Thank you. Of X and plus stringified version of X, and then I don't have a color change here. I want lowercase new here, by the way. How do you get? Why is the table being difficult on color? There you go. All right, fine. So there's a version that's alternating ints and strings, and you could imagine if I let you get up to larger. You get the second type that's being shown there. You're missing a comma I. Yeah, there you go. Comma int. Yeah. And when someone says, asks a question, JSON equal 5 by 5 approx, right? I don't know what your comment is there. Like JSON has a couple of types it deals with, and I could imagine. The unrolling is to allow you to skip from one to the next. I don't know what 5 is the right number for JSON types in general. Yeah, there's true, and then there's whatever.
True,
you're
false,
watching
null.
That's not the count for the count I'm looking for is the depth, where I switch types and I come back around, not the unique varieties. Like I have ints and I have strings, and I can have true and I have false, and I have nulls and I have arrays and I have objects. I have those already. That's not the cutoff count. So no, to answer the 5 by 5 approx, the answer is no. That is the wrong dimension you're scaling out on. I'm scaling out on the dimension that says I have a JSON which has a text string of a person's name is : string name, and their phone number is : and then a number, and so on and so forth. And they built a JSON object, and then whether I take that JSON object and crush it but preserve all the field names or not depends on how deep that JSON structure goes and how deep I'm willing to have my types go before I notice that you're cycling and come back around. If you just have a person object that doesn't have any recursive persons within it, that I'll never approx on because I don't ever roll back onto myself with it. So you'll get the JSON of a person structure directly, perfectly. It's if you have a person has a recursive person that I start to like say, oops.
So if I have a line in my program that just says load JSON object.
Yeah.
At compile time, you have no idea what that is.
That's correct.
You don't get that data until runtime.
That's right.
How do I deal with that in something like AA?
I'll give you a bad JSON approximation of a blanket JSON statement. So in the case of JSON, it's always got a lot of text. If you want to make a JSON object, like you're calling JSON on your JSON text string, what do you want for that as an AA type? I'll give you a generic whatever your JSON type is, which probably says I have a tagged enum to handle true, false, null, and whether it's number, string, array, and then I have a generic wrapped. What would you do with Java? Replace.
Do you plan to let enums have payloads? Can I have an enumerated type that says I am a
That's a different
null,
function
true,
altogether.
false, or a thing with a 8-byte
Yeah.
payload, or a thing with a pointer to a string,
So-
or a pointer to an array?
Break apart tagged unions from enums.
Right.
Tagged unions, I think exactly the point is they have a payload. Enums, I want them to behave like C people think of enums. They're boiled down to a small integer with a known tiny cost model, but they have this great semantic meaning associated with them that they're only usable in context. I can't mix up my gallons and my yards and my meters when I'm sending a rocket to Mars and shit like that, right? The enums have a tag type. They only appear in the correct places. And then you can do like completeness checking the no, because you can do that on tagged unions as well. But
So how do I express a tagged union in AA?
I don't have the syntax, special syntax for tagged union right now. I might eventually have one, and I might just say you can write one not too difficultly in the normal AA syntax. So, you know, there's a thing that says once I have a enum that I understand the range on, and I can do completeness checking at your switch statements for the enum size, then a tagged version of the same is you put that as a field member and you have tag bits elsewhere, and I don't, it's not too much of an extension from there. So I'll probably start with an enum that is a small dense integer that is well typed and floats around. I have named integers already. I'm not too far from having an enum with a scale, scope, or whatever. Adding fields to that means I boxed a number and added fields. Well, you know, semantically, I'm boxing numbers already. Like performance-wise, they're not boxed. Semantically, they're boxed. Wrapped, I'm calling it. Fine. As soon as I say I'm a wrapped, you're wrapping an enum, or yeah, and tagged integer, which is known to be a member of an enum, you're got a tagged union already. So I think I'm really close to having a tagged union syntax, but I haven't nailed it down yet. As semantics, I have it. Someone's got their cursor sitting on my quote, quote plus I. You can do that to, you know, toString if you wanted to, but quote, quote plus I is the Java short way to get a string out of an integer.
So we stray a little bit from the recursive types, but it's okay.
No, it's fine. But that's conversation slowed, so I'm throwing out
Right, but JSON is one of those cases where I tend to reach for recursive types of like, it is very convenient. One of the things that often makes me reach for Python for a quick and dirty scripting hack rather than like Rust is I want to just read some JSON data and play with it and not worry about, what are the types that I need to even be able to load this JSON document.
But yeah, you have to come up with a type, but the type here, you at runtime, you didn't know the structure of the type beforehand. And so you have to somehow represent, either you know what type you will have, a tuple maybe or something, or you don't know and have to approximate somehow an object or something that can hold all the variety of types as you want.
Right, there's a different thing that says I know what type my JSON is supposed to be, and I present that type to the compiler who validates my JSON, but then hands me a type data structure that has the JSON exploded out. And then there's the version that says, I don't know what type I'm getting. And you do like what JSON does, you get a nested point which carries the semantic overheads at every layer in order to track what it is that JSON parsed, right? No shortcuts allowed. I think that's pretty standard.
You can mark what the types supposed to be, and the compiler will try to make it or fail somehow.
Well, that's the runtime library. Like suppose I tell you what the type's supposed to be, and you parse some JSON WAD, which is not that, but it's close. So you fill in everywhere where it matches, and everywhere it doesn't, you stop and you have another version of a JSON node in your graph that said, and here's shit that wasn't what was supposed to be. And I flip over now to the generic JSON parser, and you get a generic type instead of a well understood type. And those could be all part of your tag enums and everything. And you could just have here I read this giant wad of recursive JSON text, and it's supposed to be this. So I gave you the schema it was supposed to be as a strong type in AA. And where it wasn't, I flipped out and gave you, the breakdown. And now you can decide what the hell you want to do with the breakdown, Do I need to change my schema to match the actual schema I'm seeing in practice, or do I just abort and say it's a broken piece of JSON, I'm ignoring this chunk?
The point
I
is
mean, that's very much a runtime library question.
Oh, yeah,
the
totally.
developer should say either if this doesn't conform,
right,
give me an error, or I can
right.
say if this doesn't conform, ignore the extra chunk, or I could say if this doesn't conform, give me the thing that didn't conform and let me deal with it.
H2O would read these giant CSV files. Well, 90% of the CSV files on the planet that are above a certain side are broken in some way or another. People's claim they're this, the heads look like that, it's supposed to be, and no, they're broken. And not just one or two, 90%, like most of them are broken.
The point of the type is to give you a structure beforehand, so you can write your code accordingly. So you don't guess. The type is given and you write the.
Right. Right. If you knew what you were supposed to be getting, you could write the code that did something clever with persons and know their names and their phone numbers, and you got an important library. But the library has to handle the case where the JSON that's given is crap. And then the library does what it does. It throws the thing away, it chops it off a null, it hands it to you under another node name and switches over to a generic presentation, and The library might recover, like giant CSV files, they have broken columns, happens all the time. We can recover on a line by line basis because CSV files have this line ending concept. So we would recover after a broken line and carry on. That was perfectly normal. We would have files where, some particular trader's logging software was broken and he would dump true binary bits in the ASCII dump of TCP packets that were handed off to the Chicago Board of Exchange, or the trades, right? This was the official trade record that was been used in the court of law to say that somebody did or did not cheat on their trades or whatever. It would have, raw binary data in it. Fuck.
So here
recover and carry on. It's fine.
Here a type means some more structure to your program. That's what
right.
It means here.
Right. There was a gradual typing effect, if you will. And you had to do something sensible. A robust production ready JSON reader is going to do something sensible when it's handed a wad of crappy shit that's not JSON. Because
if you have to figure out the type, it may be this type or this type. You have to introduce option to somehow.
The real story is you get handed some really bad crap that's just not JSON at all, and you didn't want to die. Threw an exception and go down in flames. No, you wanted to have some polite message came back. I don't think this is a JSON file. Are you sure? Yeah, fine. So I'm in the land of approx. That's where I'm at right now. I'm in the middle of whacking approx. It's doing much better. I have a much better, stronger story. As far as I know, this is the last of my theory bits until I meet the next theory bit I have to go deal with before I'm back to hacking. Like I got partway in, yet again, into the main core AA code base, and I ran into a question where I saw my approximation of the AA was giving me a very poor answer that I didn't like, and I didn't think it was correct. So I went to the theory side and I wrote that same approx, and it gave me a very poor answer. I didn't think it was correct. So I hand stepped it through and was like, no, this sucks. So I went and changed something on the theory side approx, and it blew up elsewhere, and it blew up elsewhere, and it blew up elsewhere. And I finally sorted it down to, oh God, I have to have step number 3. I have to have property number 3. So then I went and rethunk myself, and I got a cheap one that gave me property 3, and it all worked, except the answers all sucked. That was the number 4. So I added a property number 4, and then it got tricky, and then I did my fuzzer. That was yak shaving for the week. That was my yak shaving for the week.
So t.approx is guaranteed to not equal t.approx.approx.
No. T.approx.
You said it was monotonically growing.
Well, shrinking. But no, it doesn't monotonically. Monotonic does not mean you must make forward progress. Same or more approximated. Same is okay. Same is monotonic. So the actual answer is approx.approx had better be equal to the approx. I want it to be close the cycle in one step. So t.approx is in fact directly equal to t.approx.approx. And I don't have that as a.
Is that one of the assertions in your fuzzer?
It's not, but it should be now that you've said that. I think it falls out of the properties I've given already, though. It's not a non-obvious fallout of these properties. I'd have to go look and see. It may not be. I may have to add it as a. It's
It
easy
may
to
come
add
out
in,
of property
sorry.
3.
Prox of 3 is 3. Well, that's just, it's monotonic. It didn't move. That's monotonic. But the list versions, I want it to get to the tight list, the approx self-cyclic list in one step, and then be done. Yeah, and then what else? I do the approx on, I either have to do the approx once per loop or once per time I call new list, which is another funny question. Where does it grow? Obviously it grows in new list, but sometimes new list of string and int is okay, and it will approx them every time. So if I do it once per loop, I get a sharper answer, except I have to have loops figured out in my SSA form at the time I call the global steps. I don't want to do it once per fee function because that happens around if statements.
So we want to call approx the minute we saw another reference of the same type. Oh.
Well, right. So the easy answer, so there's a whole range of approx. So I gave a set of 4 properties, but that within that set of 4 properties, there's clearly a range, because the not suck pretty much says I could go to bottom. That sucks, but it's valid. It makes just property 1, 2, 3. So I have a range of approxes.
We have to stop it to give it the most precise type. It knows, so
yes, I want to make some trade-off between more precision and more cost.
Mm-hmm.
So if I say that I have the cutoff is set at 2 or 3 or 4, I get structures which quickly fan out to that depth, which I carry around. Now the structures are all 2, 3, 4, not 2 to the n power bigger, or 2 to the 3 or 2 to the 4 powers bigger. They get exponentially bigger as you increase the cutoff.
So you have to develop some type schemes, as they say, to try to recognize the type. Is it this type? Is this kind of hierarchy? Is this kind of a recursive type, or this kind of recursive type? So try to.
Yeah, what I'm really doing is I'm saying I'm going to set it to 1, get it working. Then I'll look to see if 2 or 3 makes enough extra precision that I fucking care.
At each step, you try to ask it, are we losing precision from this point on?
Yeah. Every time you call prox, you generally lose precision. If you come back to the same answer, you didn't lose precision. Yeah, but the whole point of a prox is you lost precision, which means you come up with a program that requires stronger types from the user, more runtime checks, or it just gets rejected.
We don't want to over approx it, so
yeah,
we have to pick them.
So there is a question here of whether you should learn some of the approximation levels from the user.
Yeah.
So it's easy enough for something like integers to say my int ranges will by default include int 8, int 16, and 32. But if my user happens to have declared a user level type somewhere in the program that says this is a number that is between 65535 and to the 32.
Yeah.
And this is a range that I think is useful enough that I typed it into my program.
Yeah, right.
Should I add that range to my approx tree because the user thought it was important enough to include in the program?
Right.
Then you hand your precision of the types to the user to type it, to try to the user has to make the precision of the type.
So, right. Roughly speaking, there's a thing that says the user handed me a type. I will already assert that you have that type or better. That's me just validating the user's given type. But when it comes time to do an approx, there's a version that says I look at the user's type and I just count the repeats and I raise my cutoff to match his repeats. And then I go hit my approx on it with a bigger number just where he says so. And that will give me an answer back that matches what he's got.
Right. The thing I'm afraid of is that somewhere else in my program, I have this type that the user is talking about that's always between 1 and 2 million or whatever.
Yeah, right. Integers are a different story. I'll just do that with the hotspot integer range game and I'm done. That'll just pick it up straight up. Because the integer range game covers lower bound, upper bound ranges perfectly every time.
Why? Doesn't it eventually give up and just widen?
No, if you have a range and you add one to a number that's generic in that range, you're out of range. You must have in the user written code something that approximates you back into range.
Because otherwise I have a bug anyway.
You have a bug anyway, that's right. So then I have a range of whatever your lower bound is, upper bound, to the same thing with a +1 on the upper bound, but then you do a wrapping function. Now the compiler has to recognize you're doing an approx. So you did a mod, for instance. Well, I can recognize mod, so I'll take a mod as an approx and I'll chop it back. That's it, we've closed the type cycle, we're done. Now you don't have to actually do anything if you chop it back to a upper bound of a constant, because I'll recognize as a constant type and I'm done. If your upper bound, lower bound are variant ints and you're chopping it in a range using mod, I won't pick that up for free. So I'll do your mod, or I'll have to tell, so I'll have to range check the value you get when you try to use it in a context where you happen to know it's been chopped to this range, but the compiler can't prove it. So I'll have to do the, array index check will be done. Now, you won't be able to skip any array index checks there. I do recognize mod though, and I do recognize, for instance, like Land of Hotspot totally recognizes mod as an index into a hash table array. You made an array of some size, you had a length of that, you mod to that length. Well, I know you're in bounds now, and after the mod function, I won't do a range check. And that was done obviously for hash tables, but it's a a little stupid one-liner precision sharpening around mod as a special case. Yeah, whatever. It was an afternoon's fun hack. Make hash table a tiny bit faster. Yeah, but in the land of list approximations and the like, if you're going to give me a type that you've spelled out, then I can go make my approx have some smarts around that type. Not that it's done there yet or anything, but I could get there. The current approx does have a number he honors that says how long he lets something get before he whacks it back for the approx. In fact, there are two interesting numbers, and I only have one of them. One is the prefix of specialty before you get approxed at the suffix, because a lot of things happen on the prefix side only. And the other one is how long of a loop. The example given here is how long of a loop do you want to go before you approx back. So I could say, for instance, that the first 3 or 4 layers I'll just let go, and then I demand a self cycle of depth 1. Or I could say depth 2 to handle this list string alternating pattern. But I claim the list string alternating pattern is kind of weird. I'm not saying it can't be happening. Obviously, you wrote it. Somebody came with it right away. You thought of it. Do you write this code actually in real life and expect to get something useful out of it? Or just make like a pair, it's got the payload's got a string and an int version, and you have a single list of pairs of more data.
Here the point being
Write this code when you're writing Lisp.
Here the point being with the type is list with something in it. That something in it has to be minimized and somehow represented by the most principal type, if you will.
Yeah,
in that game, it has to tell it it's a recursive type of list with something else, and this something else I would try to figure out.
The Henley-Milner side of things would chop your list off at depth 1 here.
Yeah, it will represent a list, but what contains
the elements, I'm saying that the element types in the list will be whacked to the union of string and int, and he'll give up right away and say, I don't know. Right.
Object. Do we have object in any type?
Well, the empty struct is basically object in that sense.
There is no just the empty struct in your language, is there?
No. You can write an empty struct. That's just oh, I don't know where I'm typing now. Where did I type?
With the alias?
Oh, here.
Are all at open bracket, close brackets equal each other?
No. Because the aliases go to the allocation site, which is the code point. I just made 2 different objects. They don't alias. They're content-wise identical. They are 2 different unique structures. So if I test them, the answer is false.
So with equals equals, I get false, and with dot eq, I get you didn't put a dot eq on those structs. What are you talking about?
Yeah, exactly. Yeah. Yeah, if they had a dot eq, then it's whatever dot eq does. And maybe Cameron would argue that I should have a default dot eq here, and maybe I could, and I haven't come there and said yes or no. But that's references being C style references. 2 mallocs happened. 2 oh man, got dropped. Coming back. 2 references got made. There are 2 structures in memory. They have different addresses. In fact, it is common enough for me to pick one as a sentinel. I make a sentinel value, and non-blocking hash table uses a sentinel for a tombstone. I say tombstone equals new object. Well, it's a new unique pointer never before seen by anybody else. It's compatible with every other thing, all things, whatever. Fine. So, oh, that's probably it. Let me go look at Matt's widening comment. That should go in the docs. Widening computer science. Oh, I'm sharing my screen. Well, there you go. Better not click my porn channels.
It comes up in abstract interpretation in a situation that is similar to your list of lists. So when you are analyzing a loop and you are trying to determine some state that may depend on the infinite number of iterations, you have to cut at some point, but you also want to have good properties of your approximation. So widening operator is pretty much, I think, what you're looking for.
Yes. I'm trying to build a correct widening operator that has the properties I mentioned, which includes whatever here.
With the
it works
caveat,
well with the lattice, even if it's a type lattice. So I think that may
it has to be right. It has to be part of the lattice.
With the caveat that there is no hierarchy of types here. There is no subtyping.
Well, there's the lattice. There's the ISA and a lattice.
Yeah, if you has a lattice, but there is no explicit subtyping here.
Okay, so this we're marching this funny edge because I'm totally faking subtyping with the lattice.
Yes, you can achieve it, but if you have a subtyping, then you have to have a bound automatically.
Oh, yeah, I have to have bounds. It's a bounded lattice.
Mm-hmm.
If I don't have bounds on the lattice, then I don't have a guaranteed termination on my algorithms. So the lattice has to have a bound.
But yes, widening is the operation here.
And widening is yes, I am doing it in writing. For whatever historical reasons called approx. Actually, in land of H2O, in land of hotspot, it was called widening. It was specifically, I said widening. And I do have widening operators floating around AA for other places where I'm doing roughly morally similar things for different contexts. But this is sort of the big one in particular because it wants to have a nice answer or whatever.
You're still sharing. Yeah.
Oh, I'm still sharing. I'm over here looking at a Twitter notification, which sometimes means I get an email on Twitter. Somebody wants to join. They're looking for the link. I follow the Twitter. And I don't know that. I'm still sharing. Okay, is it time to quit sharing? Are we done with this?
I believe so.
I had one more syntax question if you scroll down a little bit. It relates more to what we were talking about last week.
Yeah.
Should you be able to index into a struct using a name?
Not right
because
now.
It sort of has a lot of cost to it. If I do something as simple as index into a struct using a name, suddenly I need to keep all the names of the fields of the struct around at runtime and generate a bunch of code.
Yeah, I am not doing that by default. If you want to get that effect, you can do an operator overload.
Highly unlikely that he'd discard that information at runtime. I mean, you can't do RTTI, reflection, mirrors.
No, I can't get at it cheaply. I can't generate code. The code that you generate for S of quote a quote is not sort of reasonably easy to emit. So there's a reflection version, which I'm not talking about, which I'm not hearing. So you said quote a quote, that's a constant string. I can totally fucking reflect on that at compile time and just turn that into a field. Fine. Suppose you put some arbitrary string there and you're accessing a random field of S via reflection. Okay. That one has some costs for which I'm going to demand that you use some other syntax. You're going to say library import reflect dot a with field quote string and then whatever. Fine. There's something horrific you do for reflection there. Or you do an operator overloading, which somebody's busy writing, which is the other option where you happen to know that the operator for I has to take fields. Now you got the wrong operator. It's going to be self-applied. Actually, you're missing another score there. Right. Now that's better. Now you're getting closer. You need another one here. You get two values. you get the this, which is implicit. And yeah, there you go. And you don't need a dot in front of that second A. Or it's the other field or whatever you're going to do there. Yeah. Yeah, this is the AA syntax in question. Oh, you need something back at the end here that does, yeah, I is B, or it's an error because you gave me a string for a field that wasn't involved. But you're basically writing the reflective code yourself. And I wasn't going to just, yeah, and then you throw an exception or you return a nil or however you want to handle whatever you want to do for it not there. Yeah.
Yeah, but if you really want that, just write JavaScript and be done with it.
Exactly. Why are you writing AA for? Fuck it, go to JavaScript. But the question is, can I write this in a reasonable way in AA? Yeah, now you have to pretty print, and I don't know what AA pretty printing looks like yet. I haven't written enough AA code. I'm doing exactly what I would do exactly what you wrote right there. I think that's a fine pretty print version. Nil can be optionally replaced with, and here I die, because you did reflection badly, but you could do that. That's an operator overload on S that would type properly and do all the right things.
Okay. So when I first started thinking about it, I was like, this would be useful. And then I was like, that's a lot of complexity. Maybe you should just write it yourself and do the overload.
Yeah, right.
And then my question was, okay, so Rust has a bunch of macros that people will just be like, and add debug to this struct. How would I in AA write a macro that says, by the way, I want to get this behavior simply?
Yeah, right. I don't have compiler macros.
I mean, do I want to be like, and
right? No, I hear you. So that adds reflective things. So there is a version of the universe that says that there's a full strength reflective library that can be invoked here to populate S with, for instance, operator overloading for supporting string-like field lookups. Or just does the string-like lookups without putting any extra code in the struct you just wrote there, the S struct.
What is the Rust syntax for add a thing to my struct?
Derive, I believe.
You mean talking extending? I know I have AA syntax for extending a struct, and that's about as short as you think it would be. Somebody busy texting me. My wife saying there's no we in chocolate. No, that's the other one. Oh, yeah, fine. California Department of Health told me to get my booster, which I already got. Fine.
Yeah, maybe the answer is in the same way you have your extending structs, that it should just be colon.
Right.
And then the name of the extra field by default.
Right, right. Yeah. So
I don't know. It's a case that made me think macros would be useful, and
well, I'm not right. I'm separately from doing reflection. I'm dodging macros. I could be argued into them at some future date. At the moment, I'm dodging macros. But reflection,
what you said earlier was macros should just come out of eval and be a standard library call.
Right, macros and reflection come out of eval. You're handwriting a reflective piece of code that's a little simpler, but I can totally have an eval reflective library that generates that code directly from the definition of the struct there and adds it. So you could have a version that showed up as an eval like thing that said, and this is the same struct, plus it supports reflective lookup.
But then again, how would you use this? Why would you use the S in a field name?
Well, that's because you're doing reflection.
Okay, doesn't mean if you can, doesn't mean you should.
No, I'm not claiming it's but there are people who will. And if you're running a debugger, the debugger has to do meta typing for everything. He turns around and hands back to you something that has to get turned into a type. Somebody has to read the debugger's content and turns into a type. That's reflection, whoever's doing it.
Yeah, this isn't that wrong. Of the S of the A should give you the type of the A, as I understand it. This has to be the type of the A when you select it. It has to be.
when you wrote the operator syntax right there, he will right now the typing system will type S as the struct it's been assigned to, and look up the operator for square brackets and find there's an operator that takes a string and you hand it a string, and that's all valid syntax and well strongly typed. I'm missing
what would be the type of this? Is equals.
This is the type of field is 1.
Oh, is the offset of the field?
Yeah. The string is the offset.
Yep. Okay.
This is a standard dictionary lookup.
Yeah. You show me what index this field is currently at.
Yeah, right. So quote a quote comes back and gives me the value for field, right? Way it's defined right now, it gives me the value for field A, which is the number 1. And if I claim that L values are just a base and an offset, or a base and a key, then you've got an L value, and you can do a lookup. That's what we just did. You can do an assignment. You can write the equivalent code for doing the assignment and all that.
So the point being here has to be the arbitrary string instead of selection.
Yeah. Now replace quote a quote with some user written string.
Yeah.
Now you're running this code at runtime and doing the lookup at runtime. The way it's defined right now, it does it with an if tree.
But here we know it's a string. If you have to leave this as the unknown operator, unknown field name, has to be a string. It has to be at runtime to query that struct.
I'm missing something here. You can have the square bracket operator can have an index that's any whatever type, and I'll just go infer whatever type it's supposed to be. There's no, you're using one as a string index, but I can write a reflective version where I said 012 to mean field 012, which maps to field A, B, C, for instance.
Okay.
And in fact, I support 012 for structs that I have strong enough knowledge about the fields. So if
you're lucky and every single call has a compile time known variable, you could apply all those functions and then drop them because the function's now dead.
Yeah. Okay, but what if you don't know what we are calling here?
Right.
And the function doesn't get dead and still exists at runtime.
And it's a runtime test. It does if quote A is equal, if quote B is equal.
It has to find the field in the struct. It has to look for it at runtime.
That's what he wrote. That's the code that's doing the operator lookup. It's doing field by field by field. If there were 17 fields, he'd have 17 steps in the if. And then you could imagine, I could put a hash table in here that has all the known strings. And it could even be a perfect hash table. I knew it was perfect. I did a 1-step lookup or I failed and and you can optimize away, but that's user written code. The system does not provide this for you as a standard part of the core language. Since I can provide it for you with fairly small amount of library code, modest amount of library code, and you just ask for it in the library, in the structure when you want the library to be invoked. And you can get something that looks like this injected for you.
The compiler to write it for you.
Yeah. Right. Okay. The compiler can write this for you straightforwardly. But I don't have a syntax right now, but I could come up with one pretty quickly. And I would say, I would take the type for the struct for S, which you made an anonymous structure. If it was a named type, it'd be a little easier to write the code for it. I'd say, capital S is colon at this type that you just wrote above. Then there's a version of S, which is S, but it's extended with the library version, which has, except I wouldn't put, something going on like this, where I'd say, call the library reflect lib. He's going to look at his type and he's going to inject a new type, a new field, which was the operator overload for doing the fields in S. And reflect library peeks at the fields of S the hard way using a val.
Okay, that seems reasonable.
So I haven't got this nailed down per se directly. I believe something like this works. Like, I'm not sure I should have a function call there. It might be that I do something like that and I get a type back that has or I get an actual instance back that's been injected. I actually want the type back that's been injected. So I have to have a type come out of that. So future versions have the reflection put in it. So it needs some love yet. It's not there.
I would personally avoid a runtime called search for the field, but
no. As soon as you say
that's what they asked for,
right?
Yep.
As soon as some guy said, "Oh, look at little s of string, whatever this string is, right? Well, string is equal to read from the user." And then he's like, "Oh, print that sucker, right? Okay, sys.print of this. Okay, print field that I read string from the command line. Go print that field, right? Well, what the fuck am I supposed to do? Okay, reflection is the only hope. It's either a type error, this program does not compile, or I'm using reflection."
That was my question. It doesn't know what's the field. It has to search for it somehow at runtime.
Right. In the definition we've given S, you actually invoke that function. And that function does what that function does. What does that function do? Well, it happens to look up the fields and return the values as if it's a dictionary read. But the function does what the function does. So in particular, the function could fire the missiles, say print hello world, do whatever the hell it's going to do.
Right, which helps I have structs that have an array at the end. I can totally have a struct that has a bunch of operators on it. And if you index me like an array, then I'm just going to go look at the array.
It's worse than that. He's dead, Jim. No, it's better than that. Because that same array struct has map and reduce as built-in operator functions on the array.
I mean, you can have
so if I write an array, I say, 2, 3, 5, 7, here's consecutive primes up to some point, dot map of whatever. The map is a, function that takes I to whatever, I squared. The array understands map because the definition of an array is it's actually a struct with the trailing array elements of whatever, but it has a map call baked into it. That's I don't have the right syntax to do it this way, but the definition of an array is a type, which is a struct. Oh, quit, God.
Wow, Google's like, man, you totally wanted to do item.
Yeah.
Oh, cool. That's cool. So there's an array equals the dollar prim array. Oh, look at this. Oh, God. Oh, man, what did I do here? Check boxes. There's all kinds of shit going on. And then there's a map is a function of I arrow, whatever the hell I write map to be. And there's a length call, which is a function, which actually gives me a primitive length. It's actually an int, whatever, fine. Yeah, whatever. So there's a bunch of things in there. So arrays will become, I don't have this going because I'm getting my types nailed down, but my goal on arrays is I'm wrapping them the way I wrap ints or floats. There's no runtime wrappage. There's a typing time, compile time wrapping, where I understand map and reduce and fold left and fold right and whatever else things people want to do there. Oh, geez, another person pops up. Well, we're like done here, Bill. Fine.
Yeah, I'm still trying to figure out the use cases of the calling.
Ask the JavaScript people; they do it all the
time.
Yeah,
I get it, but you can separate that. You can factor this in a function call that S has to be a struct and has to have these fields.
No, you're going at the wrong way.
Okay.
Go write JavaScript. Go join a JavaScript project and write JavaScript for a year. You will understand. You may not disagree ever, may not agree ever. You may think this is stupid ever. You will see it time and time again. And then people know that it's coming. So they're all ready for it. So they have all these algorithms and libraries and whatever shit that do this dynamic lookup all the time.
Yeah, I get that, but I don't know.
Yeah, right. So like React and React Native and got Mob and what are these other things that do state management have exactly these kind of wrappers where they basically take all your normal fields and turn them into properties that have functions executing assigned to them, because they do incremental DOM state update when you change a function, and you can write your JavaScript that maps to the DOM and has some state that you're displaying on the DOM, and you can go write your normal algorithm for your application to just update the fields, and all the magic updates happen behind your back.
Okay.
All by doing this kind of lookup
Yeah. And
code injection continuously. You inject 13 layers of code. Everyone does this.
You can do this and just hope that your struct has this field instead of just select it.
Oh yeah. It hasn't failed before. Why it's going to fail the next time I call it?
Yeah,
so the optimizer optimizes, and
Yeah, that's my point. This is a gamble, at least to me, at least to my.
Oh yeah, totally. Like I said, the JavaScript JITs have different problems. Like when Java came out, I had different problems in C code. I had to optimize different things than C code did. Okay, I did it. It works. Fine. There are a bajillion null pointer and range checks in Java. They all disappear. And most of them disappear to the cost gets cheap and you're done. Okay, JavaScript does this all the time. You can optimize on this if you're a running JIT, and you can do type following, and you can do update and side effect following. You can witness that this guy has an A field and has an A field the last umpteen times through. So tell me if something removes the A field, okay? But if it hasn't been removed, then I'm going to turn it into a field offset and I'm done.
Yeah, I kind of.
That's the shit that JavaScript JITs deal with.
Yeah.
They do a decent job. Java's still faster than JavaScript by an interesting amount for any large, complicated thing.
Mm-hmm.
But they drag this forward a long way. Now, the thing that bugs me, of course, is it's weakly typed, and therefore you don't. It's hard for me to understand what the fuck's going on. So flow script and TypeScript, it gets a little better.
I get this. If you do this, you go against your type. You generally go against your static type system.
Yes, it totally defeats the purpose of a static type system. So does reflection everywhere. Java supports reflection in a strong type system, except that reflection in Java is actually broken that lets you cheat. If it didn't let you cheat, it just gave you a way to set and read fields that were mutable. I'd be okay, just be you're defeating strong types. But no, it lets you say, this final field is not final anymore. I'm going to change it after I finally assigned it.
So you can picture it, yeah.
And people do that.
It doesn't have to be like that, and it can be.
Yeah, it can be.
And it can be type safe as well. I mean, reflection can be type safe.
Yes, I agree. JavaScript blew it. Oh, here I'm sharing on Boost. We got a link for. I'll not share on Boost.
JavaScript doesn't have types, so it's as type safe as it was designed to be.
Yes.
Yeah.
Runtime types.
That's why when the code becomes ever so big, you need the types because they ensure your structure of the code. You're
preaching to the choir, sir. You need to go stand up at a Node.js conference and say that. Be prepared for Rotten Tomatoes.
I'm willing to say that. I'm willing to say that.
And all y'all are dumbasses for using JavaScript.
No, I won't say they're dumbass. This is a style of preference, but I prefer my types. They ensure some property.
Excellent choice of words. I much prefer this, not your dumbasses. That might save you a beating.
JavaScript is just the modern version of BASIC. I mean, we've all used type-free BASIC before, and we could make things work by will effort.
I don't know, Cameron. There are some younger folk here. I'm not certain that type-free BASIC's been used by everybody here.
Well, some people are lucky enough to have never had to do it. So.
Oh, excellent. I like the way you put that. That is good.
But I mean,
although increasingly JavaScript is shifting from being our BASIC to being our assembly.
Yeah, there's that attempt
to be the platform because they lack types. Sorry.
No, because
assembly is not strongly typed.
The browser is another kind of a virtual machine that lets you run arbitrary programs all over the web.
And JavaScript became the platform, not the language.
Debatable. I'm working in JavaScript right now, actually. So it's cute. Like it's cute.
Are you adding any typing layers?
No. I'm using it for UI stuff.
You can still add types there, but it's fine. Yeah.
I'm learning React.
Oh, excellent. I have done a couple of big apps in React. I have. If you're learning React, I actually recommend Mob on top of React. That's the state management. Once you wrap your head around the state management, it actually shrinks the code a lot and cleans up all kind of buggy corner cases you haven't thought of yet. So I did TypeScript, I did FlowScript, Mob and React is my main stack on top of plus Babel and whatever other things you had to have to get compatibility with everything and whatever shit. The stack was horrific.
Is that Mob X?
Yeah, it's probably MobX. Yeah, because it's a React version of Mob. Yeah.
At some point, we're going to have to make these stacks shorter.
I'm sorry?
At some point, we're going to have to make these stacks shorter and be like, this is how you talk to the graphics card. This is how you get stuff from the camera. Like,
well, React is trying to do that. And because a camera on a Mac versus a camera on an Android have substantially different capabilities and security issues. So there's some papering over that has to be done there.
Did they add security to Android now?
They've had it. You can say no at every step and then it goes. Right, I know. But as far as I know, I could not fail to ask the user with an Android pop-up that I had no control over what it looked like, that asked, can I use your camera? Right, this is me writing this inventory tracking system using tags inside factories and stuff. I've talked about this in the past. Anyhow, one of the things you had were a bajillion little tiny tags which Bluetooth echoed, and you could track them in a 3D grid moving around. One of the things you wanted to have was a QR reader on a tag, so a guy could walk up to it with his phone, wave it in front of the tag, and get the inventory management that was associated with this device. So we needed a camera to do a QR reader. And lo and behold, you had to ask permission when you installed the app. Can I use your camera? And I could preface it and say, I'm about to ask you, can I use your camera to go read the QR codes? Please say yes, or we won't be able to read QR codes. Right?
I believe you can structure the Android for Android to ask you for permission to use the camera just once. And once you agree.
Yeah, well, yes, okay. On install, at first time startup, but really I did it at first time startup, I had to go. So if every time I changed the app myself as a developer, which was 15 times a day, I got that message 15 times a day.
Yeah.
And you could put yourself in debug mode on your Android, and then you could get around it or get away from it. But the end user experience was going to be when they installed, ran it for the first time, it would pop up and say, hey.
Yeah, and users are so programmed that pop-ups are useless and annoying that they say no to everything. So you really do have to prompt them and be like, okay, I'm about to ask you a question.
Right.
Actually read it.
Right. Also, it was company specific private info. So you had to log in with a company provided name and password. And I had to go through the standard password layer as well. So, and React, like I said, they did a decent job, but not an infinitely free job of covering up the difference between Mac and Android, which were different and had different permissions and different kinds of things that you had to ponder, considered important by the different categories of people.
Yeah, the interesting thing about React is the React Native as well. So
well, that's the point. Yeah, I'm sorry. You said React. I assumed React Native.
Ah, okay.
Yeah, you're gonna log into your clustered cloud computing environment on your phone to go check status, whatever. Hey, you're writing an app, a mobile phone app. React's a reasonable way to write a mobile. React Native is a reasonable way to write a mobile phone app. Fine. Given all the options as there was of 2 or 3 years ago, React Native, I say hands down beat Angular.
Yeah, there's not a lot of options. There's React and Flutter, I guess, and that's about it.
Right Flutter was the new one, was coming along. It wasn't ready, but I was starting it, but it might be ready now. I haven't looked at Flutter. And you could certainly imagine a better setup than what React gave you.
The only other one I've really seen that anyone's tried to use is the Microsoft. It's Microsoft now, but they got it when they bought Miguel's.
I looked at a bunch. If you name it, I probably know it.
What was the Mono? They bought Mono.
Oh no, there was one baked in with Mono. I would say stay away. Yes, right. Stay away from that one with the 10-foot pole. There was some stupid, really bad issues it had. Like you had to have an entire Microsoft dev stack and you weren't going to run on a Mac. But that wasn't the main issue. There was some other, that was bad, but there was some other issue. And I don't remember what it was, but like all normal.
You can run Mono on a Mac.
No, it's the cross-platform UI.
Yeah, right. C# run everywhere.
XMRN or something like that.
Yes.
Yeah, right. It was one of the It was one of these. I stared at it. It had giant negative reviews for reasonable things. I went through the first step of download, install, look. It failed many tests of sensible use cases in a JavaScript environment, and I backed away. And I kept reading, and people said Angular and React, but modern people like React better. I tried React. I looked at Angular and what it was doing, and I stared, after I had used React for a while, I understood the syntax and what your choices really were. And I like how React's doing it. It's reasonable. Then I threw MobX on top. That had a big improvement over React alone. And I had to have TypeScript or I was going to die for no types. The no
So has that changed your opinions on what should be in a standard library and how you should expose stuff to users?
Well, that was how I got to this path that we were talking about. Look at all this shit, and here's all these libraries, and remove the stack or not, or whatever. The thing that you get out of the JavaScript, it's all at runtime, is that you can add these stacks. The stacks add value. The JavaScript guys back in the day would never have said React. So somebody came along and said, hey, React, cool. And they made this React thing, which does a substantial part of a highly back and forth reactive application stack. It changes your mindset about how an application stack works. So go to Elm, which is a strongly typed version of React, very, very strongly typed with no side effects, 0. You have to wrap your head around it. Once you do, you can really much easier write big, nasty, complicated applications which have a lot of highly reactive properties to them. You click, shit happens. You click, shit happens, right? But you need to still be safe and typed and track all the side effects and all this kind of stuff. And wrapping your head around the different coding style was totally worth it. So I claim that you couldn't have done reasonably a React over Java. It would have been more difficult to do without going hog wild on reflection. But you can go hog wild on reflection in Java. It's done. I've done it. Okay, maybe. So maybe you could have reflect in Java. I mean, React in Java. But it wasn't a bad thing that React came along as a mindset to deal with reactive applications. So, you know.
Yeah, I pasted in the link for the C# one. It's called Maui. That's what they call it now.
Oh, I only glanced at Maui. I remember the name. I walked away. There was an XFR that I stared pretty hard at. There was, I want to say, a mono-based thing I stared pretty hard at that failed pretty badly. Like I stared for more than a month at these things before I finally picked one and started diving down the damn, stack. Up to then, I was still writing TypeScript, and then I was writing, JavaScript, and then I did FlowScript. That was really nice. And had to push the types through everything. And then I kept staring at the React guys and what they were doing and why, and React Native. And I was like, I got it working on my laptop. I need it on my browser and my mobile. So let me go try React Native.
It is quite amazing that something good came out of Facebook.
Yeah, no, I think React was a good thing. And then MobX over React was kind of a fun extra hack that actually cleaned up the app. And the combo, MobX, React, Native, and whatever, I think was worth it. And TypeScript or FlowScript, pick one of the typing languages. I think that's a reasonable development stack on the JavaScript side for doing a complicated web app. And I had a web app that had a mobile scrolling, zooming map that had filters for thousands of widgets you could or didn't want to show because thousands was too much to show, and you had to pan and zoom, and you needed timelines for things, you inventory management for things, you needed history of various kinds and roll-up summaries and all kinds of shit going on in the mobile app. It was pretty complicated. QR codes, obviously. So, there's a lot of stuff happening there. I claim it's reasonable. Now, having said that, is there a better answer? Well, yes. Am I writing it right now? Well, no. But having seen how you could improve over just plain JavaScript with React and MobX, that's obviously the next step up. So if something happens better, maybe Flutter's it. I don't know. All right, we're noon o'clock-ish. It's 2 hours. It's time. Anyone else? Any last minute comments? All right, until we meet again.
Okay, bye.
Bye.
Bye, everybody.
Thanks, everyone. Bye.